So this is a presentation, a variation on a presentation I've given under different times with basically the same name 3 or 4 times over the years. So every year the project moves, and over the years I've gotten to the point I can actually now point at people in the room and say thank you. So this is a really nice time. Basically, thanks to Alan Cudmore's suggestion, who's not here, in about 2 minutes we put together a list of submissions and that had been up a long time, and MMS has had a really good run. You guys have done great. The SDO has done great. ESA Plank, I think Maria or Daniel can correct me, is that 7 years now? And the other one is actually ran out of coolant. So Plank is still up, but Herschel ran out of coolant. Okay. And NASA Fermi, a friend of mine's sister from college, it's like 3 blocks from our office. They're 8 years on like a 3-year mission, so this is, boldy go. We got Solar Probe Plus, we remembered coming up, WFIRST and ExoMars, and Cygnus apparently launched this morning, and that looks like a bucket load of RTEMS on it too. So glad they got off. So the first thing we do, and internally we pick on ourselves that our release cycle for 4.11 was measured in major life cycles. So I think we counted 4 kids, a grandchild, a PhD, a new professorship, and some other stuff on the core team. So we shame ourselves internally, but what we did is something every long-lived project needs to do. Sometimes you have to realize you have to just throw out the old processes and the old tools and focus on your core software and go, and we've done a lot of that. So a lot of this has happened over the years. The big focus, though, the word is reproducible. So now the RTEMS source builder builds the tools for you unless you snapshot the binary. We actually just have changed source code controls, media, wiki, bug tracking systems. We just converted from Tech Info, which apparently I was the only one left who actually knew how to write Tech Info, so people would send me ASCII, and I had to turn it into formatted documentation, to Sphinx, which was a fairly painful conversion, but we got confirmation that the Linux kernel had also been fighting the same conversion battle, so we're at least going to a modern tool that somebody else will know. The big one, and we'll need actually some sponsorship to help this, we've converted most of the except the core RTEMS over to WAF, which is a Python-based build system. It will cut our build time down from checking out of Git from about 10 minutes to about 30 seconds or faster on reasonable hardware. That'll be a huge win for continuous integration testing. So, but the other thing is that little things like converting to Git, we had to throw out all the release infrastructure. So it's just all this stuff that nobody wants to do, that this all got done as volunteer stuff. But then we found out, I think 4.11.1 was released 1 day after 0 because the first person who hadn't commented, obviously through the 5 release candidates, the version number never got marked on any of it. So it's like, okay, that has to go. That's not going to stand. But at least we could do a release in a day. So that's good. There has been, 4.11 had functional but experimental SMP. And the big thing is that it's on the architectures basically everybody in this audience cares about: Spark, PowerPC, and the ARM. 4.11 had a lot of new architectures, a lot of features, JFFS2, dynamic loading, there's capture trace engine. There's always a huge path to remove warnings and turn more warnings on over time, because that's just it. I'm not going to do this. There are a lot of more BSPs than were in the previous release, and there were new ports and lots of new BSPs. Since we provide our own tools, these are the versions that we're using right now. And if you notice, they're actually still pretty recent. Some of the BSPs, the DTC is the device tree compiler. So on some of the system-on-chip BSPs, they're actually using the device tree now, which is what you have to do when you can generate your own CPU. For those who don't know, the move from providing tool binaries to providing, letting you build it, means that you actually can get both a binary image that you can distribute yourself internally under your own configuration control, and the day you build the tools, you actually get all the source with checksums, so you can put it under configuration control. And that's a lesson we learned from Alan on MMS. They got a 10% throughput improvement on the processor by turning on strict alignment in the C library, and that never would have gone back into a general build, but it was obvious that it was the right thing to do. And it's pretty obvious that all of the projects go a long time, and at some point you're going to have to deal with something that's not a current version. So this is really good for long life missions like we support. think I did this slide last year. There are a lot of pieces in the tools. The tester has come along well. It's can test on test drive real hardware or simulators. The RTEMS loader is to it and the trace loader. The RTEMS loader is for the dynamic loader packages, and Ryan has got a lot of experience with that. And the trace linker, the GNU tools have a way to automatically wrap your functions when you link them. And that's a tool to read the ELF and dwarf information, and based on a template of a function you provide, you can automatically generate trace functions that wrap them so you can log or trace the entry points and exit points. The capture trace engine is SMP aware and it can trace events. And then there's tools to analyze coverage test output and generate reports, which you can run on simulators or your own hardware. Basically, we would like to get the test coverage so it's basically on a directory or subsystem basis. Right now you get a coverage number for a large block of code. This is really hard to read, but this is what the new documentation looks like. I assume the Linux kernel documentation will probably look similar because it's all coming out of the same Sphinx package. We completely rewrote the how-to, the intro and getting started. The goal is to put some inline programming examples now, BSP-specific how-tos, because a lot of people use the same BSPs, like the Leons and the Zinc and a few others account for a large number of users. It's a good way, it's easy to write, so just to put the tips and tricks everybody needs. We want to merge the the C library documentation. So those of you who should remember, we use the same C library as Cygwin, and they auto-generate their documentation out of the source header files. So it's like Doxygen, but not Doxygen, and so they got a program called Chew, and if we can update Chew to produce Sphinx, then we can merge their documentation. So that's 4.11. The funny thing is 4.11's been frozen actually for quite a long time at this point because we were redoing the documentation and fixing all the process issues. While we did that, 4.12 got all the way up to the branching point, and now we expect with a couple of GNU binutils, GCC, and newlib are at the edge of a release. There's some cleanup stuff to do. Ryan had, we wanted to double check their issues and a couple other people's to make sure everything was merged. But I'm hoping for February to branch 4.12. Actually, I hope for this week, but it's just not going to happen. That was the hope back in October. One of the cool things is the SMP has had enormous improvements, and it has a lot of state-of-the-art algorithms to avoid priority inheritance, priority inversion problems. The new TCPIP stack is performing beautifully. There's always general additions and BSP specific. There also is an effort to remove a bunch of old BSPs. So the SMP, now we have clustered scheduling, which allows you to assign different schedulers to different subset of cores. So you can actually run different scheduling algorithms on different cores. So for example, the first core could be running simple normal priority scheduler. The other 3 cores could be treated as an SMP system, so you could float tasks around. So one could be analyzed just like a traditional real-time system. There's C11 and C++11 features I think are fully supported at this point, including the tasks, the locks, the condition variables, all those things. So the SMP features, we've got Affinity that's API compatible with Linux and BSD. 2 SMP schedulers, advanced mutex locking protocols that are appropriate and analyzed in academia for SMP systems. So in gathering the presentation, I mentioned in a comment that there were great frameworks for distributed and parallel programming that came down out of the supercomputing and people, and essentially we're now running small 20-year-old supercomputers on our phones and things, if you think about it. So there's good practices. OpenMP is now supported out of the box from GCC for RTEMS. It's been tested up to 24 cores. There's some performance figures on the website in some of the tickets where the optimizations were done. There's also something that Siemens sponsored called Embedded Multi-Core Building Blocks, and that includes the message passing interface and a lot of lockless infrastructure to write applications that are SMP and capable. I mentioned the locking improvements. There's two clustered scheduling aware algorithms for priority inversion avoidance, and they're the academic references from those. You can just read them. RTEMS 4.11 has a big kernel lock. 4.12 has fine-grained locking, so that's a big improvement. Lock profiling is there. The timestamp algorithm has been, and watchdog timeout scheduling is all SMP scalable now. That pretty much linearly scalable, and the capture engine is a lock-free. At this point, the SMPs, the multi-core Sparks are fully supported. The Q or IQ series, see the slides, now that's Broadcom. They used to be Freescale, then it was NXP, now it's Broadcom, so you know, read the Wall Street Journal and my slide has to change. The Altera Zinc is well supported. The Pi 2 is supported. The Pi 3 will probably work once the UART is actually moved on the chip. I think it's the same peripherals. Interestingly, nobody has stepped up to do the little bit of work to get the x86 back up to snuff on SMP, which I think says a lot about our community. So when I was gathering information on this, I wanted to throw you guys a heads up. Click Plus was from Intel. Intel has actually laid off most of the people working on this and quietly says use OpenMP. So if you think you want to use that on an embedded system or anywhere, I would tend to stay away from it. There's another which I thought looked cool. It was an open accelerator library in GCC, and when I started asking the core developers on GCC about that, they said it's very vendor specific. It's a shame, but you probably want to stay away from that and go to, like, I think CUDA. I don't think those are going to be cross-platform and cross-architecture enough to be interesting. I don't even think the Kilk Plus has ARM support, which ought to tell you how Intel specific it is. The libbsd TCPIP stack, we were asked to write an article in the FreeBSD journal on how we did it. The paper's out there on the table. The cool thing, that slide says 9.3, but probably by the middle of January, it will be based on FreeBSD 12. Wi-Fi is supposed to be turned on. All the drivers that are in the FreeBSD tree actually work. It also includes the PF packet filtering, USB mass storage. It also, the cool thing is you configure it and tune the stack just like you were doing a FreeBSD system. So it looks, the whole stack came over largely unchanged. It's very cool. The port is described in the paper. The I2C SPI interface now is Linux compatible. Thanks to Daniel doing the work to merge it, there's a dynamic driver manager and an enhanced PCI bus library that Geisler submitted. The dynamic library supports most of the architectures for RTEMS, and there is a new multi-threaded GDB Remote Server which is aware of the latest versions of the protocol. So the GDB server, basically you can do remote network-based debugging, kind of standard stuff, but will work with Eclipse. Daniel mentioned there's an Eclipse protocol that we probably also ought to support, so you skip the GDB layer, but this is pretty neat. You can read the slides at any time. Basically, this works on 386 and ARM, and right now the main transport is TCPIP. So if somebody wants it to work over a serial port, that's possible, or support other architectures is possible. The thing with tools like this is they are architecture specific, so they take work. This is a very dense slide, but basically it's showing the target side of what you see, and if you notice, that's the TCPIP stack coming up, doing a network interface, and then bringing up the debug server. And here is an incredibly dense GDB session showing some thread awareness. The commands in red are the things, the user interaction, but basically it's just a multi-thread GDB session, and the PDFs will be up, so it's not worth really boiling down to it. The ARM Atmel ATSAM5, a lot of the models are supported. A lot of the models just vary in RAM size. So there's an enormous number of processor models and system on chips supported there. The PC has evolved quietly behind the scenes without any of us really noticing, and we all have noticed like the serial ports disappeared. They're almost, the legacy hardware is virtually disappearing off of them. So the PC BSP has had a lot of work to support like PCs where the UART is actually on the PCI bus instead of being, so you'll have a lot of PCs that have no I/O space to speak of anymore. So there's still some stuff to do there. The Raspberry Pi and the Beagle continue to gain peripherals. A lot of GSOC students, and the Raspberry Pi TCPIP is pretty close now. But for those of you who don't know, the Raspberry Pi NIC is on the other side of the USB bus, so it's particularly painful to deal with compared to normal embedded hardware. 412, I think somebody mentioned, I'd mentioned this for a couple of years, that I thought it was time to just start killing things that were out of date. And we removed, I think, about 50 BSPs, and then about 30 ARM BSPs came back. So it was kind of just making room in the closet for more stuff, I think. We are expecting to use the latest version of everything that's available. GNU BenUtils has got 2.28 coming out any day now. NewLib generally has an end of year, 1st of January release. We'll move to that. And GCC, I think, has just branched 6.2, so we'll probably cut the branch with that. So for the most part, that's our nominal tool set that 4.12 will use. There's always work to do because, like, out with the old, in with the new, there's things that need to be done. The WAF build system, a lot of the infrastructure has worked, almost all of it has been done on pure volunteer time. Chris Johns did most of like the Sphinx conversion, and then he and I at the Google Mentor Summit spent an entire day locked in a room finishing up and tidying up bugs in the conversion process. But the WAF build system is going to require a code freeze for a period of time to rip the old build system out and put the new build system in. So that's actually going to have to be some funded work. The PC BSP, some of this stuff is harder and a little time consuming. Somebody could do it, and it needs to just happen. One of the ideas is actually it would be nice just to start over and assume you're on a dual core or higher and just do everything with non-legacy hardware, get rid of 386 and 486 support completely in the new BSP. The Pi 3 needs a little bit of work to come up and be completely functional. And really we'd like to see more SMP capable BSPs, but we're pretty much there. Goddard has expressed interest in a microblaze port, and we've been gathering information on that. But mostly improvements come when the community supports the project. It was interesting hearing people talk about the agile method, and we try to be agile, but really we don't know what's coming because we don't have a master task list. You know, something will just show up out of the blue. So like making sure Shrek's issues are all dealt with. I only just took a picture of the slide and posted it so we could work through the lists of what they said. That's got to be done for the next release. So telling us is what matters. There's a lot of improvements and changes, and we're really still working through the infrastructure issues, but the releases are going to get back onto before we switched to Git, we were doing a major release about once a year and doing about 6 bug fixes releases. They were about every 6 weeks. About every 4 or 5 bugs, we would do a dot release on a release branch. And the infrastructure, at least for the release process, is back up to snuff to do that. The community has been better at funding core developers. And I mean, the community's always been fabulous about contributing new features. But always remember that even if you do all the work of getting it working yourself, somebody has to do a code review on that stuff and actually merge it. So they're actually, there's no free lunch, and a lot of the stuff gets done. Like Bob said, we program at night. We work and then we go home and we contribute. But NASA and the European Space Agency and the space community in general has been very supportive. And you guys have done some really great work over the years. And I think most of you who've used RTEMS have contributed something, whether it's large or small. The dynamic library, Alan sponsored that work. I'm trying to think what else has been sponsored. One of the file systems has been a NASA contribution. The ESA, I've mentioned multiple times, has sponsored a lot of core developers work over the past couple of years. I mean, in fact, they probably sponsored most of the work on SMP from 4.11 to 4.12. And so, I mean, that's what really has to happen, because some of this work is really hard. BSPs, people will contribute, but there are other things that are just harder and they don't happen. But that's where the project is, and I just want it to be the best for all of you and enable you guys to do great science, because that's what it's all about. So, so other people reviewed the slides, but you probably know the victims of that. So, so if anybody has any questions, I'm happy to answer them anytime, and thank you guys. Oh, good.
Okay, well, I'm alive. Okay, so it's throwing you the money.
And one thing I have realized after 27 years as a project is it wouldn't exist as a project if it didn't have users. So thank you all for just using it, and because unused software dies.
So I had a question about the Xilinx Zinc RTEMS port. So from what I understand, it requires the use of the Xilinx tools, the Vivado or IC or any, I guess, the suite of Xilinx tools to sort of to build that BSP. Is there engagement with Xilinx to sort of ease the process of sort of bare metal C applications being able to run on the Zinc?
Their boot process is pretty complicated, because I mean if you start with something like a Z board or a pre-configured Zinc or the Shrek, it's just another system on chip. But if you start generating your own custom chip, then that's where you get into problems. They have gotten a little better, but the output of the tool periodically changes, and that is the input for where all the peripherals are for the BSP. So that there's been some work to try to automate that. The other problem is that they generate like a bootloader that is like just a blob. And I think by default, a lot of your application ends up in this odd blob with the bootloader. So it's kind of odd, and I mean, we've talked to you about that kind of has to be separated, because your bootloader should be just done and fixed. You should, even if you're designing your own CPU, at some point, the CPU and the bootloader should be fixed, and then you just should be loading an application on it. And their process merges some of that in a way that doesn't promote good configuration control. So you just need to be aware of it, so you end up with a pretty traditional configuration manageable situation. It's complicated. But yes, we talk to them and are trying to push back. It's gotten better, because we've been meeting annually with them for about 5 years, and echoing up everything we hear from the RTEMS community. So,
Other questions? Okay, thanks, Joel.